In this video, let's talk about how to graph a cosine function that has a bunch of different transformations. Now, if you're still just getting used to graphing these types of cosine functions, I encourage you to check out some of my previous videos where we do some with less transformations or just even looking at the parent function. You can find a link to that in the description box below, where I have a bunch of PDFs and answer keys as well as videos linked to help you kind of understand the process and building up to a more complicated version like the one in this example. And if you want to go ahead and print out a blank PDF that is linked there as well, you can go ahead and do this with me. All right, let's get started. In this function, we have f of x is equal to -3 times cosine of this 2 pi x plus 4 pi plus 1. Just like in all the previous examples we've done, we're going to go ahead and use this formula here, where if we can identify a, b, c, and d, that'll help us a lot with going ahead and graphing this. All right, so our function exactly in this form is going to be f of x is equal to, and we have this -3 out in front. Let's go ahead and multiply that by cosine, and I'm going to throw in brackets here to keep things more organized. I'm going to factor out the coefficient of 2 pi. That's going to be our b value. That's going to multiply by this x, and we have a minus in our formula, so we're going to put that in. And then we have what? We're going to have to put in a -2 here, just because if we go ahead and distribute that out, we can see here that, let me just show you in just a moment actually. We can see here that 2 pi times this x does get you the 2 pi x. And then if we have this x minus -2, keep in mind we have a minus in the formula, so c is -2, not +2. And so this would be x plus 2, and then 2 pi times the +2 would get us that 4 pi. So hopefully that makes sense, but I just want to keep that super clear. And then at the end here, we do have a +1, so that's going to be our d value. So here's a, b, c, and d. And so I'm just going to write those in as each of our values. All right, once you know these 4 different pieces, I think the rest of it is going to be a little bit more straightforward. We just have to know how to use them. All right, talking about the vertical and horizontal types of reflections, those are going to be looking at A and B respectively. So for the vertical reflection, look at A. If A is negative, which in this case you can see that it is negative, then we're going to say yes, we're going to have a vertical reflection or flip across the x-axis. As moving on to the b value, we can see that b here is equal to 2 pi, so that's a positive value. So if it was negative, we would have a flip across the y-axis, but in this case it's positive, so we don't have a reflection there. All right, for the amplitude, that's just going to be the absolute value of whatever a is. So in this case, absolute value of -3 is going to be 3, so that's the amplitude. So we have a vertical stretch. Now for the period, we have a formula for that. So the period is just going to be equal to 2 pi divided by the b value. Now, by default, the parent function b is equal to 1. So that's why the period is 2 pi for the parent function for cosine. But in this case, it's going to be happening a little faster, I think, right? So in this case, we can see that b is equal to 2 pi here. So if we go ahead and plug that into our formula here, it's going to be 2 pi normally, but in this case, it's happening faster. We're going to divide by 2 pi. 2 pi divided by 2 pi is equal to 1. So instead of it taking 2 pi or 6.28 to complete one cycle, it's only going to take 1 for one cycle of this cosine function to complete. All right, for the midline, it's typically y is equal to 0 for the parent function. This is really dependent on the value of d. So if d is typically 0 for the parent function, then it's y equals 0. But here we can see that d is equal to 1. So we're going to say that we have the midline, which is an imaginary dotted line that just kind of shows us where the middle is. It's going to be at 1. So the midline for this function is going to be at y is equal to 1. Now to figure out the minimum and maximum y values, so for a minimum y value, 1 minus 3 is going to be -2. That's the lowest our function will go. And then 1 plus 3 is 4, or +4. That's the highest this function will go. All right, typically we like figuring out what our 5 critical points are so we can make a table and go ahead and graph it. But in this particular case, it's going to be a little bit trickier because we have a horizontal shift. So we're going to wait on that for just a moment. Next, it's always a good idea to think about what the parent function looks like. So for cosine, it always starts at the positive y-axis, 0, 1. Then it comes down to the midline, down to the minimum, back to the midline, and then back to the maximum. So just remember, this is what cosine functions typically look like for the parent function. And then everything that is going to be transformed on it will change this a little bit. But this is what it looks like by default. And here are those critical x values that we use for the parent function. Again, it's really just 0, 90 degrees, 180, 270, and 360 degrees. So it's a full circle. So try to think back to that unit circle as well. And then the y values are just going to be 1, 0, -1, 0, and back to +1. All right, so to figure out these critical points here, we have to look at what the parent function typically is and then see what kind of effect maybe one of our variables had here. So the one that we need to know for left and right or moving the x values is this c value, right? So because c is equal to -2, what we know is going to happen for each of these different x values is everything is going to be shifted 2 units to the left. So it's important to know that our parent function starts where x is equal to 0, but keep in mind that our c value, which is -2, tells us that we're going to be moving 2 units to the left. So our starting location is actually going to be at -2 instead of 0. And to figure out the end point over here, we have to look at what our period is, right? So we know our period is equal to 1. So in 1 unit, I guess, we know that we're going to have 1 cycle complete. So if we're starting at -2 and it takes 1 to complete, so then -2 plus 1 is going to be -1, right? So we know we're going to be starting at -2 and ending at -1. So while the parent function starts at 0 and ends at 2 pi, which is about 6.28, that's how long it takes to complete one period or one cycle. In this one, we have it start at -2 and end at -1, so it's only taking 1 instead of 6.28 to complete one period or one cycle. All right, so if that's true, what's halfway between -2 and -1? That's going to be -1.5. That's exactly halfway through. And then for a quarter of the way through, what's halfway between -2 and -1.5? That's going to be -1.75. And then what's halfway between -1.5 and -1? That's going to be -1.25. All right, at this point, I think we're ready to start talking about our table for this function. All right, so for this function for our x values, let's go ahead and just take these ones over here that we just solved for. So it's going to be starting at -2. That just means that the original starting point moved 2 units to the left because c was equal to -2. That tells us where it should go. And we also figured out that everything was kind of being scrunched up into just a period of 1. So it starts at -2, ends at +1. And we can just fill in everything in between here. So we have -1.75, -1.5, and -1.25. So those are going to be our new x values. Now another way to think of how to get from each of these x values to each of these x values is we can go ahead and take each of those original x values from the parent function and we can go ahead and divide them by 2 pi because it's just whatever our b value is. That's right over here. Now if you're dividing it by 2 pi, you can also think about this as multiplying it by the reciprocal or multiplying it by 1 over 2 pi, right? So those are the same things. And then you also have to shift everything and move everything 2 units to the left. So you're going to go ahead and do that. And then you're going to go ahead and just move 2 units to the left or just do -2. So if you took this 0 here, you multiplied it by 1 over 2 pi, just like this, and then you moved it 2 units to the left or subtracted 2, you would end up at -2. If you took this pi over 2 over here and you multiplied it by 1 over 2 pi, you would end up with positive 0.25. And then if you go ahead and take away 2 from that, you're going to end up at -1.75. You can take this pi over here, multiply that by 1 over 2 pi, you're going to get positive 1/2. Positive 1/2 take away 2 is going to be -1.5. If you take this 3 pi over 2, multiply by 1 over 2 pi, you're going to end up with positive 0.75. Positive 0.75 take away 2 is going to be -1.25. And finally, if you take this 2 pi and multiply it by 1 over 2 pi, you get positive 1. Positive 1 take away 2 is going to be -1. So that's another way you could think about this. So basically the value of b and the value of c are going to help you find out each of our x values. Moving on to our f of x or our y values, those are going to be affected by our a and d values. So to figure out each of our new y values here, we're going to take each of our original y values and apply some transformations to them. Basically, we're going to take this each of our y values and multiply them by our a value, and then add whatever our d value is here. So if we take this 1 here, we multiply it by -3, that's going to be -3, plus 1, that's going to be -2. If we go ahead and take this 0 here, our next y value, multiply it by -3, that's still 0, plus 1, that's going to be a positive 1. Taking this -1, multiply it by -3, that's going to be positive 3, plus 1, that's going to be positive 4. Taking the 0 here, that's going to be same as this 0, so I'm just going to say that's going to be 1. And then taking this 1 here, which is going to match this 1 in the beginning, if this was -2, we're also going to put -2 here. So essentially we do have something called a vertical stretch here because we multiplied everything by this factor of 3, but we also flipped everything here. So we essentially did what? We multiplied everything by this -3. So that caused a stretch and a reflection. And then afterwards, we also had to add 1 to each of these because we had a vertical translation because D was equal to 1. So to get each of our new Y values, we took our original Y values, we multiplied them by A, and then we added D. That's one way to think about it. And then for our X values, we took all of our X values, we divided it by basically our B value, or multiplied by 1 over B, and then we went ahead and added our C value, which was -2, and that's how we got all of our new X values. All right, now that we have this filled in table, we can go ahead and graph this. All right, now feel free to space out your X and Y axis however you'd like, but I went by halves on the X axis and I went by 1 along the Y axis. All right, as usual, I'm going to start by drawing the midline at Y is equal to 1. And we found out that our minimum Y value was going to be at -2 because the amplitude changed that, so that's going to be right here. And remember, we found our max Y value to be at 4 just because the amplitude moved it up here. So this basically just helps us hone in on where our function is going to be, but basically we have our -2, -2 here, -1.75, 1, that's going to be at our midline, which is going to be right here. Then we have -1.5, 4, that's up at our maximum. And then we have -1.25, 1, back to our midline. And then we have our final point here of -1, -2, which is back down to our minimum. So drawing a smooth curve through these points, it's going to look something like this. And remember, our parent function would typically start up and then come down and then come back up, but just because our cosine function here had a reflection, it's kind of doing the opposite because it got reflected, right? So it's starting at the bottom, then it's coming up, then it's going back down. And it's a lot taller and skinnier because we multiplied it by 3, where the amplitude is 3. All right, so this is what we essentially had from our table. So this is going to be 1 period. And we could essentially continue this pattern to the left here, going back to the midline, to the maximum, back to the midline, and then to the minimum, back to the midline, to the top, and then back to the midline and to the minimum. So drawing 2 more periods to the left, it would look like this. And drawing 5 more of these periods to the right, it'll look something like this. And so while sometimes you just need to draw 1 period, here are 8 of them, so you can see it just repeats. All right, so there you have a graph of this particular cosine function. It had a lot of different types of transformations. Hopefully you feel a little bit more comfortable with the process and how to kind of get to this point. If you found the video helpful, please consider sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.